Hello everyone and welcome back to Tech with NK. It's been a long while. I had a few things that took me off, but I'm back and ready to keep running. So today we're going to continue with our progress in Python programming and introduce a library called NumPy. So NumPy is an important library for working with data science, machine learning, and also numerical analysis. And this video is going to guide you through the essentials of NumPy. And as you can see on the screen, we're going to start by setting up our environment. Then we're going to look at how to create arrays. We're also going to look at array shapes and how to reshape them. Then we're going to dive into array operations, indexing and slicing, and then conclude with a practical example to kind of sum things up together. We're going to go through all the fundamentals in this video, and so I encourage you to play it from the beginning to the end and not miss any bit of it. So that said, let's get started. And the first thing we need to do is to ensure that our environment is ready for all of this. So what we need is to install NumPy and then import it. If you already have NumPy installed in your PC, then that's fine. If not, we do not need to go through the terminal. We can install NumPy directly from Jupyter Notebooks. And while we are at it, if you do not have Jupyter Notebooks already installed in your PC, do well to check out the description on this video, as I'm going to leave a video which I created to show you how to install NumPy and set it up to run with Python. So talking about installing NumPy, this is going to look the same like how we do it in the terminal. We're just going to run a pip install NumPy, but we're going to use some special Jupyter Notebook syntax with this percentage sign here, and then add a pip install NumPy. If I run this code cell, it's going to tell us I already have NumPy installed. But if you do not have NumPy installed, then this is going to do the installation for you. And I'm going to add one more code cell here in which we're going to import NumPy, which is easy. All we need to do is import NumPy as np. This is just a standard followed by most Python programmers. So I'm going to run this code cell, and then we have NumPy already imported. So what we need to look at next is how to create arrays. I'd like you to have in mind that there are a lot of ways to create NumPy arrays. In this video, we're just going to cover a few, but that's all you need to be able to create as many arrays as you want. So let's say we have a list. Let's call this list 1. And in this list, I'm just going to add some random values from the top of my head. 2, 5, let's say 6, 18, 24. Let's put in some negative values and let's say 0. And then we're going to use this list to create our array. Let's call this array list underscore array. And this is going to contain np.array. That's the function used to convert list into arrays. And all we need to do is to pass in our list 1. So if I run this code cell, let's add another code cell here to display list 1, or sorry, list underscore array. If I run this, then we have our array 2, 5, 6, 18, 24, negative 2, and 0. And Jupyter does a good job telling us that this is an array and not a list. Well, in this case, we needed to use a list to build our array. But what if we want to build an array from nothing? Well, there are other functions to handle that. One of these functions we're going to look at is a function called zeros. So let's create another variable. We're going to call this one zeros, and I'm going to call np.zeros. And if you're thinking like me, then yes, this function is used to create an array made up of zeros. And as you can see on my screen, my server of Jupyter is kind of helping me out here, telling me that the parameter I need to enter here is the shape of the array. And with our first example, we had a 1D array, as you can see here. But let's say we want a 2D array, and let's pass parameters 5 and 3, which corresponds to the shape of the arrays, and this tells us the number of rows we want and the number of columns. So 5 rows and 3 columns. Let me run this code cell, and here instead of displaying list underscore array, we're going to display zeros. And if I run that, we have a 2D array with 5 rows, 1, 2, 3, 4, 5, and 3 columns. And by default, these values are floats, but we can change them to integers if we want to. Let me just come back here. If I put a comma and then I pass the data type to an int, and I run this code cell and I run this other one, and we have zeros, which are integers and no longer floats. And so come to think of it, if you can create an array of zeros with the function zeros, is there one to create an array maybe of what? Maybe let's say ones with the function ones? If you are thinking in that direction, then you're absolutely right, because that's the next function we're going to look at. So let's create another variable. Let's call this one ones. And in this variable, we're going to call the function np.ones. And I'm sure you already know what this function is going to do. All we're going to do is just pass in the parameters again, 4, 3 for a different shape. And let me run this. And I'm sure you already have a picture of what is going to be displayed on our screen when I run this code cell. And yes, we have an array with 4 rows and 3 columns filled with ones. And now I'm thinking, is there one for twos and what, threes and fours and fives? I mean, thinking about it, it will be quite cumbersome to have functions for all of those values, which is why they don't exist. However, NumPy has ways to accomplish that. Like one way is to use, let's say, what this np.ones function, and let's say you multiply all the elements of this by the desired value. If you want maybe an array of fives, you just need to multiply this by 5 and it gives you an array of fives. Also, there's a function called full which can do this. Feel free to check it out later on to see how it works. And for those of you interested in numerical analysis, there's this function called np.I, which is used to generate the identity matrix. So let's create a variable here. Let's call this identity, and I'm going to set it to np.I. And we're going to give it a shape, let's say 5. If I run this code cell and here, instead of displaying ones, we're going to display the identity. And if I run this, we have a 5 by 5 matrix, pretty much a square matrix with ones on the diagonal and zeros elsewhere. So these are a few ways we can use to create arrays in Python. And to give you a little bit of terminology, our 1D array here could also be referred to as a vector, while our 2D arrays here could be referred to as matrices. And there's one more way I want to show you here. Let's say we want a random matrix. Let me create this variable random underscore matrix, and we're going to use a NumPy function np.random.rand, and I'm going to give it the parameters 3 and 2, which will serve as a shape of the matrix. And if I run this code cell and let's display a random matrix to see what it contains, random matrix, and I run this, we have a 3 by 2 matrix. We have 3 rows, 2 columns with random values. Now the way this rand function works is it generates random values between 0 and 1 with 1 exclusive. And I think this should do for an intro on creating arrays. Next, let's look at array shapes and array reshaping. And this is important because as you keep programming, working with NumPy arrays or vectors, there will be times where you want to know probably the shape of your array and other times where you want to reshape it for the purpose of your analysis. And NumPy comes with an attribute called shape that tells us the shape of an array. And let's try running this on any one of our arrays that we have here. Let's say we're running with the array ones. To do this, we're going to run ones.shape. And if I run that code cell, we have our output 4 by 3. And if we come back here, we see that we defined ones as an array with 4 rows and 3 columns. But then, if we already know the shape of our array, and instead we're interested in reshaping this array, there's a NumPy function called reshape that can enable us to do just that. And let's say we want to reshape our array of ones. To do this, we're going to call ones.reshape, and then we're going to pass a parameter for the new shape that we desire. Remember that our array once had a shape 4 by 3. Let's say we want to change the shape to a 2 by 6. And if I run that, we have a new array because reshape returns a new array. It doesn't modify the original array. A new array with 2 rows and 6 columns. And to show you that, let me add another code cell here, and let's say we run once again. We see that our array once is the same. And thinking about this, how then does the function reshape work? I'm going to leave a little comment here saying this works if the product of the row star the columns of, let's say, what the old array is equal to the product of the row and columns of the old array, of the new array, sorry. So what does this mean? Our old array, which is this one, has a shape of 4 by 3. the product of which is 12. And having that in mind, we can reshape ones with any of the multiples of 12, which means ones could be a 2 by 6 array, it could be a 12 by 1 array, it could be a 3 by 4 or a 4 by 3 array. So that's that with reshaping. And next, let's look at array operations. To do this, I'm going to create some new arrays to work with. Let's forget the ones we already have. I'm going to call these arrays, let's say array 1. And I'm going to show you another way to create random arrays. So we're going to call np.random.runInt in this case, and no longer rand. And the parameters for these are almost similar like our parameters rand, with the difference being that we get to choose the range over which our random values are being selected. Let's take a small range for this example, and we're going to take values from 1 to 3, and we're going to give this a shape. Let's say we want a 2 by 3 array. Nothing complicated. Let me copy this and paste this also here, and I'm going to modify this. Instead of array 1, I'm going to call this array 2 with the same shape and same range of values. And let us display this to see what these arrays look like. So I'm going to display array 1 and array 2 by each other. Around that code cell, we have our two arrays. Array 1 has 1, 1, 1, 1, 2, 2, and array 2, 1, 2, 1, 1, 1, 1. If I run this again, the values should be different and the values change as you just saw. And I'm going to create variables to contain these operations. The first I'm going to call sum, and in this variable, we're going to sum array 1 and array 2. So let me run this code cell, add another code cell below here, and display the results. We have an array with 3, 3, 3, 2, 3, 2. And from the results, we see that basic array operations take place element-wise. This means that adding array 1 to array 2, we have 1 plus 2, 3, 2 plus 1, 3, 1 plus 2, 3, and so on and so forth. And all the other operations look just the same. Let's say we want to deal with subtraction. Let's create a second variable and let's call it the difference, and we're going to subtract array 1, or rather array 2 from array 1, and array 2. If I run this and I display the difference here, we should have a different result. We have 1, negative 1, 1, 0, 1, 0, which is just element-wise subtraction. Now, if we want to look at division, we could go ahead and put array 1 divided by array 2 here using the division sign, or we could use a NumPy function to help us do that. Let me create another variable, and I'm going to assign this to np.divide of array 1 or array 2 by array 1, and this will work just the same as doing array 2 divided by array 1. And if you're thinking about it, yes, NumPy also has a function for subtraction and addition. But I just wanted to show you that you could actually use the actual operators, or you could use NumPy functions to do this. So let me run this code cell, and in this box here or in this cell here, instead of running div or diff, we're going to run div, and we have our result, element-wise division. And we can go ahead and look at multiplication, but there's one thing I want to say first, is that there are two ways in which we could multiply arrays here. We could do the element-wise multiplication, that if we just use like the star and say array 1 star array 2, or we could do matrix multiplication, which is very different from element-wise multiplication. And let's just write the code to see what this looks like. Let's create a first variable. I'm going to call this prod for what? Product of two matrices, and I'm going to call the function multiply from NumPy, and we're going to multiply array 1 with array 2, and I'm going to create a second variable. I'll call this dot, and in this one I'm going to carry out the dot product, which is pretty much matrix multiplication of array 1 with array 2. And if I run this, oh, we have a little mistake here, because well, we can multiply array 1 by array 2 because the shapes don't match. I'm going to multiply this by the transpose of array 2. And just like that, we've just seen another matrix property, which is obtaining the transpose of a matrix. So let me run this, and this time around that should work. I'm going to display product and the dot product by each other for us to see the difference. And as we can see, Product contains the element-wise multiplication of these two matrices, whereas dot contains the actual matrix multiplication of these two matrices. And with this, I think I'm going to leave it at this point for matrix operations. There sure are a lot of operations we could look at, logarithms, exponentials, and all of that. And feel free to check that later on by yourself. But the next thing I want us to look at is indexing and slicing. Because just like we saw before with lists, we can also carry out indexing and slicing with arrays. And the syntax is quite similar. To show this, I'm going to create a third array. Let's call this one array3. We're going to set it to np.random.runInt, and we're going to pass the parameters. This time around, I want a wider range, let's say from 1 to 7, and I want a different shape. Let's say we have a 4 by 5 matrix, and if I run that and display array3, let me run this code cell. We have a random matrix or a random 4 by 5 matrix with values ranging from 1 to 7. And thinking about it, we can visualize an array almost like a list of lists. And if you recall, we use two square brackets to be able to extract values from a list of lists, which is one way to carry out indexing with NumPy arrays. So let's say we want to get, let's say in the second row here, we wanted this element 3 here. How are we going to do that? We're going to call array3. We'll open our first square brackets. Let me remove this, come back here, and we see that 3 here is in the second row. So we're going to use 1 here, because remember we're counting from 0. 0, 1, 2, 3. And in the second square brackets, let me remove this, we see that 3 here is in 1, 2, 3, 4, the fourth column. So here we're going to pass 3. And if I round that, we have the element here, 3. Pretty straightforward. Think about it just like working with a list of lists. And with this same syntax, we can extract slices from our array. Let's say we want, for example, the second and third rows here, all the elements in the second and third rows. What are we going to do? We're going to call array3. We'll open our first set of square brackets, and we want the second and third rows. So we're going to take elements from 1 to 3, because remember 3 is excluded, and so we're going to get 1 and 2. And in the second set of square brackets, since we want to get all the elements in the rows, we're just going to get all the columns. And if I run that, we successfully extracted our second and third rows. You can compare the values to ensure that. But before concluding with indexing and slicing, there's one more method that we can use to obtain these slices with NumPy arrays. And so instead of using two sets of square brackets, we're only going to use one. And let's say we still want our second and third rows like we did before here. The syntax for this is going to look a little bit different, but the idea remains the same. We're going to call array3, and in a single set of square brackets, I'm going to pass our row slices, that's from 1 to 3, and I'm going to put a comma to indicate that those are the rows that I want, and now I want to work with columns, and I'm going to select all the columns. And if I run this, as you can see, we have the same output here. So you can look at this as slicing with array, square brackets, row, comma, columns. And with this, having your previous knowledge with lists and lists of lists, you should not have any trouble with indexing and slicing. And finally, we've come to the end where we're going to work with an example of our own. So I went ahead and added a little bit of text here to define our problem statement. So assuming we are working with the city's weather data for a month, represented as a 2D array where each row represents a week and each column represents the daily high temperatures in degrees Fahrenheit. We're going to analyze this data and then use that to calculate some useful statistics. And the first thing we're going to do is generate random data for daily highs between 60 and 80 degrees Fahrenheit, calculate the average temperatures for each week, get the highest and lowest temperatures in the month, and identify temperatures above 70 degrees Fahrenheit. And you can picture yourself maybe working for this news channel. You've been given a bunch of data, and then they want you to like extract from that data probably like the average high temperature over the month, or maybe the average high temperature per week, or they want you to like tell them what's the highest temperature throughout that month, what's the lowest temperature. And the data for a month, maybe it's not a lot. You could probably just look at a sheet and extract all of that. But let's say maybe you're working with data for like, I don't know, for the past 5 years, for the past, I don't know, 10 years, maybe trying to obtain some analysis that, well, what has been like the average increase in temperature over all of these years. And so with this, I just want to give you like an idea of how you could be able to do that later on. Well, coming back to this, our easy example, the first thing we're going to do is to generate our random data. Let's create a variable. Let's call this temperatures. And in this variable, we're going to create our data and store it there. So np.random.ren int. Let's just create like random integers for this case. Like I said, an easy example. And let's say the temperature varied from 60 to 80 degrees. And let's give it the size. In this case, we know that we're working with a month's data. And so we're going to give it a size of 4 by 7, which represent 4 rows and 7 columns for 4 weeks in that month and the 7 days of the week. But before running this, let's display our data and see what it looks like. And this is what our data looks like of 4 by 7 array. We can see that on the first day of the month, this day here, the temperature was like 67 and then 71 and so on and so forth, with the last day being 73. And so that settles it for the data. Next, we're going to calculate the average temperatures for each week. It's a good thing our creators of NumPy were good mathematicians, because they created the main function that can help us do this in just a single line. So we're going to call this function np.mean, and we're going to pass our data to it. Let's say we pass temperatures to it. Let's run these and see what happens. If I press shift enter, we have a single value. Well, what just happened is that we found the mean of all of these values. That's from 67 here to 73. And so it didn't do the mean for the separate rows, which is what we actually wanted. Well, there's a fix for that, because the main function has a parameter called axis. And this parameter, if we set it to 1 and then run this code cell one more time, and setting the axis to 1 has the effect of calling the main function on each row separately. So row 1, 2, 3, and 4. And so we have an array with 4 elements which correspond to the average for each row of our temperatures. And sure, you can play with this axis parameter a little bit if you want to, because instead of setting 1 here, we could set 0 here. And if we run this, now we have 7 outputs. That's 1, 2, 3, 4, 5, 6, 7. And so we can already guess that it calculated the mean per column. Let's say maybe you wanted to find out the average temperature on Mondays, Tuesdays, Wednesdays, Thursdays. Then you can set the axis parameter to 0 instead. But in this case, we're asked to do it for each week. So I'm going to return this to 1 and I run this, and we are done with that. Our next task is to get the highest and lowest temperature in the month. And yes, NumPy has the functions to help us do this. We're going to call np.max to get the maximum temperature. All we need to do is to pass our temperatures to it. And just beside this, I'm also going to display a minimum temperature, calling np.mean and passing our temperatures to it. And if I run this code cell, we have our maximum temperature, which is 79, and our minimum temperature, which is 60. Well, we could easily guess that, considering that we have random values from 60 to 80, and we know 80 is not included. And just to give you some little stuff to look into later on, the max and min functions also have the axis parameter. And I'm pretty sure you know what I want you to see with this. So I'm just going to remove this and leave the rest to you. And the last thing we're going to do is we're going to identify temperatures greater than 70 degrees Fahrenheit. And there's one functionality of NumPy arrays that is going to help us do this, which is Boolean indexing. This is a little bit different from our regular indexing which we've been seeing, where we wanted maybe a specific value or a slice of values, where we use just the rows and columns to get a whole chunk of data. But what we are able to do with Boolean indexing is we can set a condition which could result to true or false, and select only elements from our data or from our array. which return true while discarding anything that returns false. So what would this look like? We're still going to call our variable temperatures. We're going to use our square brackets for indexing like we always do. But instead of setting maybe some rows or columns here, we're going to put a condition, which is for temperatures greater than 70. And now when I run this, we see that we're able to extract every temperature which is greater than 70. That's from 71 to 79. And anything less than, like we see it is 67 here and 68 here, 62. Anything less than is not included. And when you think about this, you see that there are a lot of things we could do with this Boolean indexing. Let's say maybe they want you to tell them, let's say maybe the days of the weeks that have temperatures above 75 and something like that. Well, with this and NumPy array, we see that we're not able to label our data. Maybe have titles for this column, say Monday, Tuesday, Wednesday till Sunday, or have like week 1, week 2, and all of that, which tells us one of the limitations of NumPy arrays, which is why we need to look at something even further, which is pandas, which we're going to discuss in our next video. So having said that, we've come to the end of this video. I believe I did my best to make it as easy as possible. However, if you have any questions, feel free to leave them in the comment section below and I'll be more than pleased to answer you. If you enjoyed the video, do well to hit the like and subscribe buttons and I look forward to seeing you in my upcoming videos. That said, have a good day.